Swayam Prabha. Digital India. Educated India.
Hello, good evening, good afternoon, good morning everybody. I am Raghunandan Sengupta taking the TQM class which is TQM 1 Total Quality Management 1. So, we are discussing in the 14th lecture about the needs between the customer requirements and how the attributes from the designer manufacturer point of view can be considered such that there is a dovetailing between the requirements with respect to the total customer needs. So, to continue that in the 15th lecture and so on and so forth. So, the QFD, which is quality functional deployment, which we are doing basically it sets the right granularity and the level of importance which is needed for each and every attributes. They do not apply to every type of projects which are there. So, obviously from the manufacturing point of view they would have a lot of such differentiation, lot of analysis, but maybe see for example from the point of view of service sector, the overall set of points in details as we discussed in the last class, which is the 14th one, may not hold, but obviously the general plan of things for all the discussions do hold. They may be possible that we give some inadequate priorities for different attributes or the characteristics. The main problem can be lack of team workmanship should be there such that the level of relationship or level of work which should be done between the designer, the procurement of the raw materials person or set of the team, the manufacturer may not be to that possible extent which you would like to have in order to meet the overall customer requirements. There may be lack of team skills for each and every level, lack of support or commitment may be there from the top level. And remember me, for any good quality improvement, the actual emphasis should be coming up from the top level who are basically the real main driving force for improving the quality in any organization, be it government, be it manufacturing, be it educational institute, be it any field. There may be, because if you are going into too much detail, there may be too much to chart for, too much details to consider, which may not be possible at the first go when one is considering the relationship between the customer requirements and the needs with all the attributes. There may be some inkling to complete the work very fast, which is not possible because quality improvement takes time. So, what may be the actual problems which the customer is trying to portray to the design team, to the manufacturing team may not be immediately applicable or immediately understood by the team, or there may be issues where the problem the customer which is actually not implementable, we are not able to portray that or tell that to the customers because there may be some miscommunication happening between the customers or set of customers and the design and the manufacturing team or the unit which is basically manufacturing some product. So, there may be failure to integrate all the information which is there between the different 4 teams or 4 stages as I discussed, and as I mentioned, the Japanese would like to basically go into details of each 4 levels, while in the Western culture we would be more interested to consider the first 2 stages considering the level of importance which is there for the QFD. So, these needs and hows as I mentioned, so in one set we will see, as we have seen, that the hows becomes the needs in the second level, and we continue in this way. So, one should review the current status at least quarterly or a monthly, and such detailed analysis should be made such that we are able to understand that in which direction the QFD and the customer requirements are being balanced with the attributes, set of attributes which we have basically thought for ourselves. So, generally QFDs should not be static, they would be dynamic. So, in case if they are dynamic, the real problems or real issues as the customer requirements change are portrayed in the attributes which somebody is considering. So, points to remember is that process may look simple, but it requires effort. Many entries looks obvious, but they should be written down in such a way that the simplicity should be coming out in the detailed perspective. So, if somebody writes the needs in the house and the next set of house becomes the needs in the second stage. So, the relationship should be portrayed in such a way that the level of correlation given the points of very strong, weak, negative should be coming out in such a way that the relationship or the importance of all the attributes between the customer needs should come out at every state, and if you combine them, they should be coming out in the best possible manner. If there are no tough spots the first time, it is probably it is being done, it isn't being done in the right time. So, obviously there may be issues, and if the issues are very apparent, but if those apparent points are not coming out in the detailed analysis, which means the detailed analysis which is being taken into consideration does not consider those points in the right perspective. Focus should always be there on the end customer requirement. So, my customer may be the second stage, the second stage customer, say for example, may be the third stage, so on and so forth, but in the overall perspective the end customer requirement are the best possible, all characteristics or the inputs based on which all the attributes are being analyzed. Charts need not be objective, so, but if they are not objective, obviously the attributes and the analysis may not come out in the best possible manner. Charts are the means for achieving those objectives. So, obviously we try to bring more objectivity in the charts, that may not be possible, but what we are trying to implement and what we are trying to basically portray is that the chart should be the ways how objectivity can be brought into the analysis between the customer requirements and the overall set of attributes which we want to consider from the designer and manufacturing viewpoint, such that the customer requirements are met to the best possible extent. We should find reasons to succeed, no excuses to failure should be found out. So, obviously we will all should basically point in the direction such that we are able to find out where the problem lies and try to basically implement that the overall scheme in the best possible manner such that the weaknesses are overcome and the success is the main motivation based on which the whole work is being done. Remember that the overall the stages 1, 2, 3, 4 or the QFDs for 4 stages as we mentioned in details should always be analyzed in such a way that a follow up should be there. We should analyze the problem from the point of view that after the first initial set of analysis one has done, we should basically be able to take the feedback from the first set of analysis and put it in the second set of analysis such that improvements are always there. So, having said about QFD, I would like to go into the concept of acceptance sampling, and this will take some time in order to understand that, and I will strongly urge my friends, my students and whoever is basically trying to understand that some amount of reading has to be done. There may be issues which may become very technical, but as I said statistics and if you remember I did discuss about the level of probability distribution, not in details, but about the normal distributions which would basically be the building block based on which we will be considering the concept of the sampling and accepted sampling. So, accepted sampling basically means is a method used to accept or reject products based on lots which are drawn at random samples of the product. So, randomly I pick up set of lots, it may be 3, it may be 4, it may be 5, whatever it is, and we pick up the lots depending on what your overall scheme of sampling is. The purpose of acceptance sampling is to sentence lots, which is basically to say them they are accepted or rejected, also known as lot disposition, rather than to estimate the level of or the quantity of a lot. So, what we want to do is that pick up a lot, study the characteristics of the lot and say whether you want to accept or reject, or basically take some in between policies. What are the policies? I will come to that later, such that we are able to take up overall objective judgment of the overall set of sampling or set of population which we have in front of us. So, if you remember that, and from basic statistics we know the overall population, which is the overall set of things which need to be sampled, it is technically not possible to sample each and every product. So, in order to overcome that lacunae, we pick up lots, and the picking of the lots and sampling the lots or testing the lots is done in such a way that we are able to give the property of the overall population from the sample which has been picked up. Accepted sampling plans do not improve quality directly, it basically only gives you the indication in which direction you should go in order to improve the quality. The nature of sampling is such that the acceptance sampling will accept some lots or reject some lots considering the overall sampling plan which you have in front of you. So, the sampling plan 1, let us mention it as number 1, may be true for some set of products which is product 1, where the sampling plan 1 may not hold for product 2, we may be utilizing some sampling plan 2. So, how we use sampling plan 1 or sampling plan 2 would depend that how the things are being done. The most effective use of acceptance sampling is an auditing tool to help ensure that the output of a process meets the requirements to the best possible manner. So, situations where acceptance sampling is likely to be successful are when testing is destructive. So, say for example, we have a testing machine or a bulb, or say for example, a product where destructive testing is used. So, if you are using destructive testing, it means that once we test that product is out of use. So, we cannot use that. So, here in situations where destructive testing is used, their sampling, lot size samplings are important based on the size of the lot we are choosing. When the cost of 100 inspection is extremely high, as I mentioned, that if rather than picking up each and every observation from the population, it is best to pick up a small set of lot and do the testing accordingly. When 100% inspection is not technology feasible or is very costly or would require so much calendar time period that the production scheduling would be seriously affected. So, time, cost and impossibility of trying to basically test each and every product are few of the important reasons why acceptance sampling is done. So, other reasons are when there are many items to be inspected and the inspection error rate is sufficiently high, such that 100% inspection might cause a higher percentage of defects. So, you want to basically pick up a lot, understand that if the lot number of defects in that lot is over a certain percentage, we would definitely be tempted or have a policy where you want to reject that lot rather than trying to find out defect in the overall population. It may be possible, other reasons being when the supplier has an excellent quality history and some reduction in inspection from 100% is desired. So, but the supplier process capability is sufficiently low, so as to make no inspection an unsatisfactory alternative from the point of view of us. That means, we are procuring some products from the vendor or the supplier, and there are, say for example, the supplier has an excellent quality history, but due to the supplier's process capability being weak or process capability not being up to the standard what we need. So, we may be forced to bring that lot sampling into the action, so that we can find out the concept of acceptance sampling in such a way that it gives us some information that what is the problem, the process capability of the supplier, and we can do two things. So, number one, accept or reject the lot and be very careful in what is the overall quality level of the products we are accepting, and also be in a position to tell the vendor or the supplier that where the problem lies from the point of view of the process capability or on his or her end. The other reason is that where there are potentially serious product liability risk, and where the risk of trying to basically get a product which is where if you basically err on trying to accept a bad product may be disaster. Say for example, for a pacemaker, or say for example, for a very sophisticated instrument which is being used in an airline industry or in a plane, or very sophisticated component which we want to use in building a bridge over a river where the huge amount of traffic flow is very huge. So, where there are such problems, we may be in a position be tempted to use acceptance sampling concept, such that we are able to be sanguine about the type of product which we are using. So, continuing that, when there are potentially serious product liability risk, and although the supplier's process is satisfactory, a program for continuously monitoring the overall process capability, product requirement and product's level of quality is of utmost importance to us. Types of sampling plans are, in a very simple way I will discuss. One of the major classifications is by data type. So, they would be either variables which you can measure using quantitative variables or quantitative characteristics, they would be attributes which would be more qualitative in nature. Another is based on the number of samples required for a decision. So, they may be single sampling plans, they may be double sampling plans, they may be multiple sampling plans, they may be sequential sampling plans, so on and so forth. So, if somebody goes into the depth of sequential sampling, you will understand the work done by Abraham Wald and the different type of sampling plans which have been given has really spurred a huge body of literature in the area of sequential sampling and sequential analysis. or inference techniques. So, single, double, multiple and sequential sampling plans can be designed to produce equivalent results. Factors to consider include what are the administrative efficiency, what are the administrative cost, type of information produced by each and every plan, to what level of efficiency we want the sampling information to be available to us. Say for example, if we pick up each and every observation, obviously it will mean that we will get the best possible sampling plan. That means we are aware of the quality level of each and every product, but the flip side is, on the negative side is that if you do the sampling for each and every product, then the amount of cost intertwined in the overall sampling process becomes very huge. On the other hand, if you take only lot size of a very big number and basically pick up only few samples to do the testing, it will mean that the cost would definitely decrease, but the overall efficiency of trying to basically predict or forecast or find out what is the level of quality for the whole population may not be to that possible extent what we want it to be. Lot formation and random sampling is an important point to be considered. So, there are a number of important considerations in forming lots or inspections, which include lots should be homogeneous, not heterogeneous. Larger lots are favored over small lots, but obviously there is a flip side also. As I mentioned that more the lot size, obviously you have to be very careful. The characteristics which are portrayed by taking a larger lot size actually give us some information of the overall population. Lots should be conformal to the material handling system which is being used in both the suppliers and the consumers facilities and at their respective ends. So, single sampling plan of attributes, as I said, single, double, multiple, sequential. So, we will just very briefly discuss the single sampling plan for attributes. Suppose that the lot of size n has been submitted for inspection. So, this n I am considering as the big so called population. So, in general we know that population actually size is infinite, but we see that if n is very large, it can be considered as a population and we can do the sampling based on the small capital N which is as mentioned here. A single sampling plan is defined by the sample size n and the accepted number C. So, there are three numbers. One is basically the so called overall size of the population, which is capital N. From that we pick up a small chunk which is small n, and we basically accept or reject that particular sample such that we have some say on whether to accept or reject a total population based on the fact that what is the accepted number C in that total sample size n. Thus, if the lot size is given as in this slide is 10,000, then the sampling plan can be that you pick up a size of 89. 89 is just arbitrary, and we find we have, depending on the past data, depending on the past experience, we put a number 2 to the accepted number C, which is 2. Means that from a lot size of 10,000, a random sample of n small n 89 is picked up, is inspected, and the number of non-conforming or defective items is observed, and we accept or reject depending on the number C, which is 2. If the number of defects D, so that we pick up, find out of the n 89 some number are defective. If D is less than or equal to C, then the lot will be accepted. If D is more than, say for example C, obviously the lot is rejected. So, if the number of observed defectives D is greater than 2, then the lot would be rejected, and we can proceed of picking up the second set of sample which is 89, or we can basically reject the overall lot depending on the overall experience which we have from the past data. When you are doing that acceptor sampling, there is a concept of consumer risk and producer risk also. So, this is very important, which will depend that as we increase the size of n, the level of so called confidence which we have on the producer risk and the consumer risk will change, and how it changes I will come to that discussion in a very simple terms. The nature of sampling is such that the accepted sampling will accept some lots and reject others even though they are of the same quality. So, obviously, if you pick up 89 each and every time, the D number in some cases may be less than 2, may be equal to 2, and in some cases may be more than 2. So, if it is less than equal to 2, we accept that. If it is more than 2, obviously we reject that. So, each time we do that, that overall acceptance and rejection would change accordingly. Thus, acceptance sampling can reject good lots and accept bad lots. So, it means that actually when you are basically picking up a set of observation, the number of defects in the overall population percentage wise. So, if you think it in a very rational form, if you are picking up 89 and if 2 or less than 2 are the total number or the percentage which is acceptable to us. So, we will say that 2 by 89 on a percentage sense would also have some implication on the overall total such population and the number of defects which we have, which means that in a very simple sense 2 by 89 should be equal to the number of defects which is there for the overall population divided by 10,000. So, if the total in the value which you want to find out, so 2 by 89 is equal to say for example x by 10,000, if x is basically that number which would be 2 into 10,000 divided by 89. So, we would be saying that that actual total lot of 10,000 size should be accepted, but it may be possible that when we pick up a size of 89, the number of defects may be say for example more than 2. In that case, we are rejecting that lot even though the total number of defects in the overall population of 10,000 would be less than the value which we have found out. So, what is that value? As I again said, I am again repeating, it would be 2 into 10,000 divided by 89. But in other case, the flip side would be, that means in the first example which I gave, that means we are rejecting a particular lot when the overall number of defects is not that high as per the stipulation which we have put for ourselves. In other case, it may be that the number of defects D is less than or equal to 2 and we may be tempted to basically accept that overall lot, but we find out, pick up each and every observation out of the 10,000 and measure it, the number of defects may be larger than the value of 2 into 10,000 by 89, which means that we are accepting a particular lot where the overall number of defects in the total lot is more than what we want it to be. So, obviously, there is a risk on both the sides. In both the cases, if we combine, the risks are, we are basically accepting a lot where the number of defects is much higher than we want it to be, and in other case the number of defects would be much lower than the one which we would basically want to accept. So, in both these cases we are facing a risk, and these risks are as mentioned is reject a good lot and accept a bad lot. So, the producer risk based on this R and the consumer risk would be like this. So, let me basically first discuss the producer risk. The probability of rejecting a good lot is basically the producer risk. In order to calculate this probability, there must be a numerical definition as to what constitutes a good lot. So, what we do is that we have a set stipulation or level which is known as the accepted quality level, which is the numerical definition of a good lot. So, if the value of the overall lot is greater than or less than AQL, which is the accepted quality level, then we make a decision whether to accept or reject that particular lot. The ANSI or ASQC standards, this is the quality standards, describes AQL as the maximum percentage or proportions of non-conforming items or number of non-conformity in a batch that can be considered satisfactory as a process average. So, if you are basically picking up a lot one after a time, on an average, if AQL value is as stipulated by the ANSI and ASQ, which is American Statistical Quality Concepts, if those values are greater or more than those particular average, we will take a decision accordingly and basically define the producer's risk accordingly. On the other hand, so obviously there is a producer who manufactures and passes on to the customer. The customer risk, and now we are going to discuss which is the other way around, the probability of accepting a bad lot. So, that means that the quality of the product is bad, we should definitely have rejected that, but that is being accepted. So, there is basically the problems on both sides of the coin. In one case we accept a bad lot, and in another case we reject a good lot. So, continuing with the consumer risk, in order to calculate the probability there must be a numerical definition, and that definition basically is given by lot tolerance percentage defect of LTPD or RQL, and which basically means rejectable quality level or limiting quality level. So, numerical definition is basically of a bad lot. So, as per the ANSI and ASQC, American Statistical Quality Control norms, it basically means as the maximum percentage or proportion of non-conforming items or the number of non-conformity in the batch for which the customer wishes the probability of acceptance to be specified to a low value. So, in both the cases there would be risk, and these risks we will see later on, and somebody would have studied the concept of hypothesis testing, they are basically the concept of level of risk which are given by alpha and beta. That means some good items we are rejecting, some bad items we are basically accepting. Now, based on this level of alpha and beta, which is the producer risk and the consumer risk, we will basically have the operating characteristic curve. So, operating characteristic curves will depend on the sample size, which depend on the capital value of n, which will depend on, say for example, the value of c, and all these things depending on the distribution which is there. So, obviously, there would be underlying distribution for the products which are being sampled. So, it can be either discrete distribution, continuous distribution, exponential distribution, normal distribution, then all this distribution would be there. So, how would you basically have OC curves based on the level of producer risk and consumer risk would basically be specified for each and every example as per the ANSI and the ASQC norms. The OC curve is a curve showing the relationship between the probability of acceptance, which is basically measured along the y axis, and the proportion defective P on the lot on the x axis. So, you will basically measure the proportion defective along the x axis and the probability of acceptance along the on the y axis. So, both these things would also entail that, as I mentioned, the capital N, small n, c values will also be considered in such a way that for different curves you will have different values of n, c and small n, or else to put in other words, for different values of capital N, small n and small c, you will have different curves which can be plotted along the x and y axis, where x and y, as I have already mentioned, basically means the proportional defect along the x axis and probability of acceptance along the y axis. OC curves are used to represent the 4 parameters, which are the producer risk, the consumer risk, which we will see are some combinations of alpha and beta if you consider the hypothesis testing concept, the AQL which I just mentioned, and the LTPD which is the RQL for the sampling plan, both from the producer's point of view and the consumer's point of view. So, the ideal plot for the acceptance sampling would definitely be not a curve, basically it will be a curve which is basically moves vertically up and then it goes straight. So, if you see the probability of acceptance are being measured along the y axis, so they are basically measured from 0 to 100, and along the x axis we have the lot quality or fraction of defective, which basically can be from 0 to 100. So, basically between a scale of 0 to 1 on a probability scale or 0 to 1 on a probability scale along the y axis, basically you will have the curve which would basically give you the information. So, this curves distribution between the perfectly between the good and the bad items. So, what you have is if you follow my finger, so generally the curve would basically go like this. So, it will be S curve, and the inclination and the way the S curve have been drawn would basically depend on the level of alpha and beta and the producer risk and the consumer risk. So, S which I am denoting may be flipped on the y axis depending on how you have been able to portray the level of lots quality and the level of probability along the y axis and the first point of the lot quality along the x axis. So, this is the ideal of the perfect operating characteristics curve. So, generally the operating characteristics curves for a general motion would be the pink line which shows the OC curves, and what is important for you for all of us to note is that the AQL or the LTPD, the values which have been mentioned by from the point of view of the customers and consumers and the producers, are marked in such a way that they will give you the level of such risk which both the parties are able to sustain without compromising on the overall quality of the lot. So, obviously, if I accept a bad lot, it is a problem for me, and in the other case, if say for example, I reject a good lot, is a problem for the customers. So, customers this from the person who I am taking the products or to whom I am selling the products. So, obviously, a compromise has to be made. So, the level of compromise would be based on the producer's risk and the consumer risk, which would be basically we denote by alpha and beta and the values of AQN and LTPD. So, the underlying distribution for numbers of defective in a sample considering a binomial distribution. Samples come from a large lot where you can either reject or accept. So, that type of curve would be known as the OC curves of type B, and for the hypergeometric distribution where you have a huge population, those would be known as type A OC curves. So, if the sample size is less than 20 units, then the binomial distribution will be hold, and otherwise the Poisson distribution will be utilized. I will discuss these in more details as we continue the discussion in the 16th lecture and further on. Have a nice day. Thank you very much.